Hello, this is Jack Jackson. We've been looking at triangle congruence criteria. We looked at the side, we looked at side angle side first, then angle side angle, then side side side, and then angle angle side, and side side angle. We have one left to look at where there's three possible measurements that could be congruent, and that would be the angle angle side. We've been looking at these in 4 different geometries: Euclidean, hyperbolic, spherical, and taxicab. We're going to do the same thing. In this video, we're going to focus just on the standard Euclidean geometry and look at the angle-angle condition there. So let's look at my app here. As always, I'm using some GeoGebra activities, some GeoGebra apps that I have put together. All right, so let's take a look here. Here we can specify an angle and a second angle. Why didn't I specify the third one? Well, in Euclidean geometry, we know that the sum of the measures of the interior angles must be pi radians, which equals 180 degrees. If they sum up to less than 180 degrees or more than 180 degrees, then no triangle is possible. So really, if you have the angle-angle criteria, and the triangle exists, you must have the angle, angle, angle criteria, in which case the triangle will exist if the three angles add up to pi in their measurement. Okay, so really if we just specify two angles, we've got it. So start with the first angle, which is of course the two rays here. That's controlled by the slider here. It can be obtuse, it could be acute. We'll check both cases out later. And then pick a second angle, pick a point B on here, and then make the second angle there. But notice we can move that anywhere we want, and we get a triangle where the third angle is down there where it makes all three angles measures add up to 180 degrees or pi radians. But if you look, there are actually infinitely many congruence classes here. And it really doesn't matter what the scenario is. It could be an obtuse angle, okay, as long as what happens? As long as that third angle, the two angles don't add up to more than pi. Now, of course, if they add up to more than pi, then this ray is never going to meet that ray. And if they add up to exactly pi, somewhere in here, those are actually parallel. And again, they're not going to meet. But if it adds up to more than pi, they don't meet. If it adds up to less than pi, yeah, they will meet at some point. And in fact, once again, you're going to get infinitely many different triangles here. So for example, there's one triangle. Okay, but here's a second one, and here's even a third one. And we see that no matter, there's not just one or even two congruence classes, or really even just three, there's actually infinitely many of them. So definitely we do not get congruent triangles necessarily by just having all the angles be congruent. But we do get something interesting. If I take a couple of these triangles, let's compare it to the original one. Okay, the original one is this one. Okay, A, B, and C, little size, little a, little b, little c, opposite angles, A, B, and C. Now look at this second triangle here. If you look at it, if you take this side and divide it by that one, it gives you a ratio, and it's constant here because if I divide this one, that length by that length, or divide this one by the corresponding length here, or divide this little length here by the corresponding one here, as long as I'm dividing corresponding sides, I get the same number. Now that may be a different number for a different triangle. Here we have it here. Okay, but those sides are in proportion. So we have proportional side lengths, and congruent angle. Okay, so the ratio of corresponding side lengths is always a constant, a different constant depending on how big you pick it, but a constant, a scale factor. Then we see that that makes us have what we call similar triangles. So similar triangles have congruent angles, but not necessarily congruent sides, but the side lengths are proportional. So this actually is, this case right here is really what makes a lot of trigonometry work. It's what makes the sine and cosine and tangent functions work. That's something for a little bit later, but we will come back to that later. But our final conclusion is angle, angle, angle is not enough to guarantee congruence of triangles. We either get zero congruence classes or infinitely